In this video, we are going to learn about financial functions in Excel, including PV function, which is present value, FV function, which is future value, determining the number of payments, determining the interest rate, as well as some functions that are used across different disciplines, which is about depreciation. Engineering students learn that in engineering economics course. It's a concept, time value of money, which may be also discussed in finance, economics, or in engineering courses. So at the end, we will also talk about depreciation as well, and what are the functions that we can use in Excel to calculate depreciation. In some examples, I have developed a few scenarios inside that example to expose you to different shapes and formats of the same formula, to expose you to more examples of the same financial function. And you will see that in a few examples as we go ahead in the lecture. So the first example is on using PV function, which is for present value. You're buying a copier. Would you rather pay $11,000 today or $3,000 a year at the end of each year for 5 years, assuming that the cost of capital is 12%? Now, cost of capital is the expected rate of return. It can be interpreted also as cost of debt or interest rate. So we can just think of it as interest rate. Now, before we proceed to what this function is and how we are going to use it and how we are going to make a decision in this example, it's important to discuss a concept here, which is the time value of money. As I mentioned, you might learn that in your economics course or finance course or in engineering economics course. It's a concept that is discussed across different disciplines. The idea is that there's a value associated with time for money. So, for example, what you can buy with $3,000 today. Now, in this example, you have $3,000 a year for 5 years. So think of you have placed 3,000 at the end of each year for the next 5 years. Now the question is that a better purchase approach? At 12% interest rate, or would you rather just to pay $11,000 today? Now, you have to think that what $3,000 can buy you this year is not what $3,000 can buy you next year. In other words, if you bring $3,000 from year two to present, the amount is going to be less. So for example, the buying power of 2,900 maybe today is equal to 3,000 1 year from now. So again, back to this example, there are five $3,000 that are placed across 5 years. These $3,000 are not offering you the same buying power. So what $3,000 can buy you this year, that's not the same as 1 year from now. That's not the same as 2 years from now. That's not the same as 3, 4, 5, so forth years from now. So the question here is that you have two options. One is that you can pay $11,000 today, or you can find the present value of making five $3,000 at a time purchases or payments at 12%. So one is very straightforward. You have to pay $11,000 today. But the other question is that if I'm supposed to pay $3,000 for 5 years and at the end of each year, what is the present value of those five payments? Knowing that, there's this concept of time value of money, because the same amount of money has a different buying power as time progresses. So the question is, what is the present value of making five payments, $3,000 payment at a time at the end of each year for the next 5 years, and the interest rate being 12%. Now, eventually what we want to do is that we would like to compare 11,000 with that amount. The one that is less is better. Basically, we are paying less to obtain the same copier. It's a thing. You can also think of it this way. Say like we did the calculations using the PV function and we ended up with 10,000. So basically the present value of making 5 payments, $3,000 at a time at the end of each year for the next 5 years at 12%, say like that became 10,000. Now, what will be the decision? It's as if someone is asking you, would you like to pay $11,000 today to buy this copier, or would you like to buy $10,000 today to buy the same copier? Obviously, we are going to select the second option, which is to pay $10,000 today to buy the same copier. So in order to be able to make a decision on which method or offer is a better option for purchasing an equipment or any other investment, one way to do that is to find the present value of all the payments, and then you can compare that with the cash option or the upfront investment. So now that we understand the concept here, in terms of what present value is, it's present value of future payments, future investments, future costs, future revenue, whatever that future is. Basically, you are springing it back to today. It can be anything. It can be revenue. It can be cost. Whatever that is, it's in future. You want to bring it back to today, and then you can compare that with upfront initial investments. The one that is less is better if it's about spending money. If you were looking at revenue, that could be obviously the opposite. So it is a function. So as we have learned, we will start with equal sign. So that's equal sign, and then we have PV, which is present value. You see that there are 5 arguments here. There is rate, number of periods or payments, payment itself, future value, and type. There are some similarities between some of these arguments and what we have learned in the PMT function in terms of the arguments that goes into these. So the rate is basically the interest rate. In this case, that would be 12% if the payments are going to be annual. Number of periods or number of payments, which is basically, in this case, we've got 5 years, because we're going to make the payments at the end of each year. So that shows us that we are making yearly payments, and it is for 5 years. So number of payments or number of periods is going to be 5. Now, as we know that the payments are made annually, then we are going to consider rate as the annual rate. So the annual rate is 12%. So far we know what the rate is and what the number of payments is. Now, the third argument is the payment itself. There's one key and important point here, and that is payment is what you pay, and inside the formula, it will go in with a negative sign because you're actually making that payment. Future value, just like in the PMT function, it's going to be 0, and type, it will be 0 if you're making payment at the end of the time unit, and it will be 1 if you're making the payments in the beginning of the time unit. And as I mentioned earlier, I have developed some scenarios to expose you to these different scenarios, different conditions, or different options. So to just take a look here at some of the notes, a payment has a negative sign. So in our case, we are making $3,000 payment at the end of each year. So in the formula, that will go in as minus 3,000. Future value is cash balance after you make the last payment. Okay, so in this example, that's 0. And type, if it is 0, that means payments are made at the end of the time unit. Now, in this case, that's a year. But if we want to make payments in the beginning of the year, that would be 1, which is 1 at the beginning of the year. And it would be 0 if it is at the end of the year. So let's now go to an Excel file and then solve this. So we have equal sign because it's a function. Now I'm typing PV. It appears here. I double left click on PV. Now we see rate. The rate is 12%. Number of periods or payments is 5. So as you see, the time unit is consistent. You have number of payments, which is in years, and that's 5 years. Accordingly, you choose the interest rate. As your payments are annual, the interest rate must be annual as well. The payment is 3,000. As it is a payment, it goes in with negative sign. So we type minus 3,000. Future value is 0, meaning that there is no outstanding balance after you make the last payment. And the type is also 0 because the example says that we are going to be making each payment at the end of every year. So as they're the default numbers, future value and type both are 0, which are the default values. As they're the default, we don't need to input them. I close the parentheses and I press enter. So we get 10,814. So you're making 5 $3,000 payments for 5 years. If you just sum them up, it becomes 15,000. As you see, the present value of those 3,000 payments is not 15,000 today. It's actually less than that. It is around $10,814. As we discussed, 3,000 today is not 3,000 1 year from now. That's not 3,000 2 years from now. That's not 3,000 5 years from now. The nominal value is the same, but the real value is different because there's interest rate involved. So you make 5 payments at the end of each year for 5 years. The present value of these 5 payments, right? Basically, bring them back to today, right? So it's a time machine. You can travel in future, or you're grabbing things from future and placing it into today. Bring 3,000 from year 4 to today. Bring the 3,000 from year 5 to today, and do that with year 3 to 1 as well. Now sum them up. What is their value today? That is $10,814.33. So that's the present value of those 5 payments. Now the question becomes easy. The question is, would you like to pay $11,000 today to buy this copier, or would you like to pay $11,814.33 today to buy that copier? And of course, the answer is going to be the second option, that we would rather pay $10,814 today, which in our example, what that means is that we are going to select the option of making 5 payments, $3,000 a year, at the end of each year at 12% interest rate. So that's going to be the answer to the question. So it is a better deal to make payments at the end of the year than to pay out $11,000 today. Now, scenario 2 is the same example, except that we are asked to make payments in the beginning of each year. So as I mentioned, I've developed these scenarios so that you will see your answers can be sensitive to these changes. I've actually developed the examples in such a way that you will see that when such information changes, it is possible that it will affect your final decision, your final approach with making a purchase. So everything is the same. The question still is, would you like to pay $11,000 today, or would you like to make 5 payments, $3,000 a year for 5 years at 12%, but every payment has to be made at the beginning of each year? Again, before we get to the the function itself, now we know what that means. It basically, the type is now changed here. Type is 0 when we make payments at the end of the time unit, in this case a year. Type is 1 if we make payments at the beginning of each time unit, in this case year. So that's the only thing that is going to change inside the formula. But just to understand how this works actually in terms of concept, think of it this way. When you're being asked to make payments at the beginning of a time unit rather than the end of a time unit, it is good for the person who is receiving that money. It is not good for the person who is making that money or making that payment. Because when you're asked to make a payment at the end of a year, what you can do is that you can invest your money, for example, in the bank for a full year, and earn interest from it and then make that payment. So basically you had control over that money for a full year and you benefited from having that money. But what happens is that when you're making the payment at the beginning of the time unit, that opportunity to gain money from that money is not transferred to whoever you're paying to. So just going into this, you should expect that this is a good option for the receiver. This is not a good option for the person who is actually making the payment. So what would change here? We still have 12%. That has not changed, which is the annual rate. We are making 5 payments. Then we have 3,000, which is the payment for each year. Now, look at the 5 arguments we have here. The future value has not changed. Future value is the outstanding amount after you make the last payment. In this scenario, that is still 0. What has changed is type. In example 1 or scenario 1, type was 0 because we were making the payments at the end of the year. Here, type is going to be 1 because we are making payments at the beginning of each year. Why I emphasize that? Now we need to input 1 for type. Just make sure you do not forget to put 0 here for FV. Remember that the PV function has 5 arguments. You will leave the 4th and the 5th arguments blank if both of them are 0. In this case, which is scenario 2, the 5th argument is actually 1. The 4th argument is default, which is 0. But you should not close this argument with 4 arguments inside parentheses and 1 being last. You should make sure that you put 0 for FV and then you put 1 for type. Because if you close this argument with 4 arguments, 1 being the 4th argument, then 1 can be actually interpreted as FV. So again, if FV and type are both 0, you can just ignore both, leave both of them blank. Close the argument with 3 arguments. Put equal PV, rate, number of periods, payment, which we just did in example 1. Now, if you see that type has now assumed a different value, which is 1, okay, make sure that you put 0 for FV because it is 0, and then you have 1, which is for type. So let's take that to the Excel file. We have equal PV. The rate is still 12%. It is for 5 years minus 3,000. The outstanding value after you make the last payment is 0, comma, and the type. See, after I put comma, I haven't typed anything. Excel actually, shows you the path. It says 0, end of the period. 1, beginning of the period. So in this case, it's beginning. So we put 1, close parentheses, and press enter. $12,112.05. So what that means to us, now the question is, would you like to pay $11,000 today to obtain that copier, or would you like to pay $12,112.05 today to get that copier? And the answer would be, if I have that cash, I would pay $11,000 today rather than making 5 payments at the end of each year, and each payment being $3,000 at 12%. As you see, everything stayed the same. The only thing that was different was making payments at the beginning of each year or at the end of each year. And as you see, it actually makes a difference in our final decision. Scenario 3, you're buying a copier. Would you rather pay $11,000 today or $3,000 a year at the end of each year for 5 years? Now, you must include an extra $500 payment at the end of year 5. Assume the cost of capital is 12%. So what has changed here? We are back to making payments at the end of each year, but now we see that FV is going to assume a value. FV was the outstanding amount after you make the last payment. In this case, it's asking you for additional $500 payment at the end of year 5. Okay, so here's the syntax or the arguments for this function. We have equal PV, 12% annually, because we are making annual payments. We are making 5 payments, so that's 5. Every payment is 3,000. As it's a payment, it goes in with minus. Now, in addition to these payments, we also need to make a payment of $500 at the end of year 5. So as it's a payment, it again goes in with minus. And this one is type. The 5th argument is type. Type is 0 if we make payments at the end of the time unit. Type is 1 if we make the payments at the beginning of the time unit. In this case, it's end, so type goes in as 0. So let's just take that to Excel. So we have equal PV. The rate is 12%. It is 5 years. We are making $3,000 payments. The future value is 500, so it's another payment, so it goes in as minus, and the type is going to be 0 because we are making payments at the end of each year. I close parentheses, press enter. It is $11,098, which basically what we have here as well. So now the question becomes easy. Would you rather pay $11,000 today or $11,098 today to obtain the same copier? The answer would be it's a better deal to pay $11,000 today. Now, one can think, well, usually when they ask you money at the end, usually it's not a good deal. I've personally heard the, kind of rule of thumb or perceptions of, how finance works. I would say that at the best, it's an opinion. The only thing that you can really trust is these formulas. So, just because someone is asking some money at the end of the last payment, meaning there's an outstanding balance you have to pay, doesn't mean anything. All that means is that you need to just make a payment. Yes. But it should not affect your decision until you come and use finance formulas, because these formulas are capturing basically these conditions. So in this example, which was scenario 3, you had to pay $500 at the end of the 5th payment. Turned out that it's not a good option. Now, I think now you know where these scenarios are going. I developed the 4th scenario to show you again how sensitive these models are to this information and why it is very important that you use these formulas rather than going with the rule of thumb. So scenario 4 is everything is like scenario 3, but they're not asking $500. They're only asking $300. Everything is the same as scenario 3. It is 12%. It is 5 years. You're making each payment at the end of each year. The cost of capital is 12%. But instead of 500, they're asking 300 after you're done with your last payment. Now let's see what that looks like. So we come back, equal PV, rate is 12%, comma, for 5 years, comma, we are making $3,000 payments. Future value is 300, which is the outstanding balance after you make the last payment, and type is 0 because it is end of each year that you're making the payments. It becomes 10,984, which we have here as well. So now the questions become simple. Would you like to pay $11,000 today to buy this copier, or would you like to pay $10,984 to buy this copier? The answer is the second option. 10,984 is a better option, which in our example is, yes, I'm going to pay 5 $3,000 payments, each payment to be made at the end of each year at 12% cost of capital, and at the end, I will pay another $300. So as you see, all it takes is just a difference between 500 and 300, which is just $200, to make a completely different decision, given that these options are available. So these 4 scenarios were basically to use the PV function to work with different rate, number of period, and payments, future value, and type. The next function is the FV function, which is future value. So the example, or one of the good examples for future value, is pension or retirement planning. So every year you put some money aside, or you invested with the bank with some programs or plans. And then what you're wondering is what that money is going to be accumulated to become when you retire. For example, you want to retire 30 years from now, 20 years from now, and every year you want to put some money aside. Now, what that's going to become 20 years from now, 30 years from now, that is, you're interested in finding out the future value of your present investments. So now you're springing forward. With present value function, you're springing back. Things are happening in future, you're bringing them to present. With future value function, or FV function, is the opposite. You are finding the future value for present investments. So the argument, the arguments, there are 5 of them inside the FV function. It starts with equal sign, FV. We have rate, number of periods or payments, the payment itself, present value, and type. Payment made each period is 2,000 in this example, so that will go in as minus 2,000. PV here is new. It's amount of money owed right now. So if you owe money, because it's about amount of money owed, if you owe money, that will go in as a positive value. If you have money in the bank, that is the opposite of owing. So you're actually in a better place. Now that will go in as negative. Again, PV is about owing. So if you owe, it goes as positive. If it's the opposite of owing, which is you have money in the bank, that will go in as minus. The rest is similar to what we have discussed before. So we have equal FV. Now, let's look at the example. If at the end of each of the next 40 years, I invest $2,000 a year towards my retirement and earn 8% a year on my investment, how much will I have when I retire? So you're making $2,000 a year in payment, which is an investment, and you want to do that for the next 40 years. And the interest rate on your investment is 8%. That's how much you're basically gaining from that investment. You want to know what these $2,000 payments that you're making on a yearly basis will actually become as a lump sum, as a total after 40 years. You will actually shortly be amazed to see how much of a significant amount it actually becomes, which is right here that we have calculated. It's around $500,000. So, and this 8% is close to a lot of plans available in the banks that they offer for retirement plans. Sometimes it's even more than 8%. So if you put $2,000 aside a year at 8% for 40 years, after 40 years, you have $500,000. So let's take that to Excel. So 8% for 40 years, and you're making $2,000 payment. So equal FV, double left click on it. The rate is 8%, so that's 8% for 40 years. The payment is 2,000. Again, you're making that payment. Yes, it's an investment, but you're making a payment. So you're paying $2,000 to that account. PV is 0 and type is also 0 because those payments are being made at the end of each year. Close parentheses, and you have 518,113. So as you see, it becomes a significant amount, after 40 years. I have done this 2 different ways to show you that there would not be a difference. So here, as you see, we typed in 2 zeros. They're the default values. We would have got the same $500,000, investment after 40 years without putting those 2 zeros. As we have discussed, when those 2 zeros, are the case, as they are the default case, we can just leave them blank. So that would be equal FV We have 8% for 40 years, and we are making $2,000 payment. PV is 0, and type is 0. So we can just close parentheses, press enter. We basically get the same value. So that would be for FV function. Now I have developed a different scenario here to show you how the outcome or the result is sensitive to or depends on these parameters. So I have reduced the time from 40 years to 20 years, the same amount of investment, which is 2,000, and I've changed the rate from 8% to 5%. So for the next 20 years, if you invest $2,000 a year at 5%, how much you're going to have 20 years from now? And the answer is 66,000. As you see, it's like significant. So, one lesson learned from here is that, earlier you start saving for your retirement, more you can benefit from it because the money accumulates as time goes on. So as you see, when it's 40 years at 8%, you end up with $500,000. But when you cut the number to 20 years, meaning you're only, saving for 20 years and it's only 5%. So seems like it's only 3% less, but you see when it is combined, less year, less percentage, the number also drops significantly. That's from like 500,000 to 66,000. So in this example, we are working with 5%. So equal FV, it is 5%. For 20 years, and the same payment, which is 2,000. PV is going to be 0, and type is also going to be 0. So what we get is 66,131, which is 66,131, and that would be scenario 2.